Okay, Chapter 3, Lesson 2, Introduction to Functions. The first thing we're going to talk about is domain and range. So if you remember from Algebra 1, the domain is all of the x terms. So it's the first numbers of the ordered pairs. And the range is the second numbers, or all of the y terms. A relation is just a set of ordered pairs. And to determine if something is a relation or a function, which we're probably going to get to, I should check. Yes, okay, so we're just going to talk about relations for right now. So example, determine the domain and range of this relation. So here's a set of ordered pairs. They are 2, 3, 2, 4, 0, -1, and 3, -1. And so the domain are all of the x terms, no repeats. So my x terms are 0, 2, and 3, and in order. So I did 0, 2, and then 3, and make sure they're in order. My range is the same thing. All the y terms, no repeats, and in order. So my range is -1, 3, and 4. Another example, find the domain and range of the following relation. So for my domains, in order would be -4, -2, 0, 2, and 4. And my range is just 1. 1, 1, 1, 1, 1. All right, so then what's the difference between a relation, which is a set of ordered pairs, and a function? So in order to be a function, each domain or each x must have its own range. So basically what that's saying is the x terms cannot repeat. The y's can. When we get to one-to-one functions, then we'll talk about how the y's cannot repeat. But for just a plain function, we only have to worry about the x's, and the x's may not repeat. The y's can, and so we're not going to worry about the y's. So example 1, here are some relations, and we want to know, is it a function? So I check out the x's, 3, -3, 8, 9. There are no repeats, so this is a function. On the second example, -3, 0, 0, 1, 6. So this is just a relation because the 0 repeated. Are linear equations functions? So think about a linear equation. So this would be like -4, -3, -3, -2, -2, -1, 0, 1, 2, 3, 4. So yes. And are quadratic equations functions? So this would be like -3, -2, -1, 0, 1, 2, 3, 4. So yes. So an easier way to do those, instead of trying to list all of those coordinates for part C and part D, is if you go back to remember what the vertical line test is. So the vertical line test says if you draw a vertical line through any part of your graph, it can only cross once. So any vertical line you draw through any part of the graph may only cross once. So this first example here, this is not a function because when I draw this vertical line, it crosses at the top of the circle and the bottom of the circle. So this one is a relation. The second one, no matter where I draw a vertical line, it only crosses once, so that's why it's a function. Same thing on this third example, any vertical line I draw only crosses once. But on this fourth example, again, it crosses once at the bottom and once at the top, no matter where I draw the line. And so this is a relation. So once we've determined if something is a function, we use what's called function notation. So instead of using y equals, we can substitute out the y equals for f, which stands for function, of x. So when we have it like this, it's read as f of x. So I change this first one from y equals 2x plus 1. Once I've done the vertical line test and determined that it's a function, I substitute f of x in for y, and I rewrite it as f of x equals 2x plus 1. So in this example, when it gives you a function, it says f of x is 8x minus 2, and it wants you to find each of the following. So in example A, they're saying in the function, substitute 1 in for x. So I write it as 8 times 1 minus 2, which is 6. For example 2, I write it as 8 times negative 2 minus 2, which is negative 18. And the last one, I rewrite it as 8 times 0 minus 2, which is negative 2.